Space is all around us, extending in every direction, farther than we can easily imagine. When we look up at the night sky, we are looking out into this vastness, a place that seems both distant and strangely peaceful. Space is not a thing we can touch or hold, but rather the expanse that exists beyond our atmosphere, beyond the clouds, beyond the thin layer of air that surrounds our planet. It is the realm where planets drift, where stars glow softly, and where everything moves in slow, predictable patterns. The universe is mostly empty. Between the stars and planets, there is a quiet void, a stillness that stretches across unimaginable distances. This emptiness is not frightening or cold in a harsh way, but simply present, a calm background against which everything else exists. In space, there is no sound, because sound needs air or water to travel through, and in the vacuum of space, there is neither. This silence is complete and total, a quietness that has existed for billions of years, undisturbed by anything we would recognize as noise. Stars are scattered throughout this vast expanse, tiny points of light that seem to float in the darkness. Each star is a sphere of gas, glowing gently from the heat within it. Some stars are small and dim, while others are larger and brighter, but all of them burn steadily over incredibly long periods of time. A star can shine for millions or even billions of years, its light traveling outward in all directions, moving through space at a constant, unchanging speed. The light we see from a star tonight may have left that star years ago, traveling through the emptiness to reach our eyes. Our own star, the Sun, is just one of countless stars in the universe. It sits at the center of our solar system, and the planets, including Earth, move around it in smooth, circular paths. The Sun glows with a warm, steady light, and even though it is very far away, its light reaches us in just over 8 minutes. This light has traveled through the vacuum of space, through the darkness, to bring warmth and brightness to our world. The Sun has been shining for a very long time, and it will continue to shine for a very long time still, a constant presence in our sky. The planets in our solar system each follow their own path around the Sun. They move at different speeds, depending on how far they are from the Sun and how large they are. Mercury, the closest planet to the Sun, moves quickly, completing its orbit in just a few months. Neptune, the farthest planet, takes much longer, moving slowly through its distant path over the course of many years. Each planet drifts along in its own quiet way, following the same route over and over again, a predictable and gentle rhythm. Space is very, very large. The distance between planets is so great that even traveling at the speed of light, it would take hours or days to move from one planet to another. The distance between stars is even greater, measured in units called light years, which describe how far light can travel in a full year. A light year is an immense distance, far beyond anything we encounter in our daily lives. Yet in the context of the universe, even this vast distance becomes small. Stars are separated by many light years, and galaxies, which are collections of billions of stars, are separated by even greater expanses. Our galaxy is called the Milky Way. It is a spiral-shaped collection of stars, gas, and dust, all slowly rotating around a central point. The Milky Way contains hundreds of billions of stars, each one drifting along in its own orbit within the galaxy. Our Sun is just one of these stars, located about halfway out from the center, in one of the spiral arms. The galaxy rotates very slowly, so slowly that even though our Sun is moving through space, it will take hundreds of millions of years to complete a single orbit around the galactic center. This motion is smooth and steady, a gentle drift that continues without pause. When we look up at the night sky, many of the stars we see are part of the Milky Way. On a clear night, away from city lights, you can see a faint band of light stretching across the sky. This band is the Milky Way itself, the combined light of countless stars too far away to see individually. It is a soft, diffuse glow, a reminder that we are part of something much larger than ourselves, a vast collection of stars all moving together through space. Beyond our galaxy, there are other galaxies, each one containing billions of stars of its own. These galaxies are scattered throughout the universe, separated by vast stretches of empty space. Some galaxies are similar to the Milky Way, with spiral arms and a central bulge. Others are elliptical, shaped more like a smooth, rounded blob of stars. Still others are irregular, without a clear shape, their stars scattered in a more random pattern. Each galaxy drifts through space, moving slowly through the universe over time. The universe itself is expanding. The space between galaxies is gradually increasing, stretching over time. This expansion is slow and gentle, not something we can observe directly, but something that has been happening for billions of years. As the universe expands, galaxies move farther apart from one another, drifting slowly through the vastness. This expansion does not have a center or an edge that we can point to. Instead, everything is moving away from everything else, a gradual stretching of the fabric of space itself. Time in space feels different when you consider the scales involved. A human lifetime is just a brief moment compared to the age of stars and galaxies. The sun has been shining for about 4.5 billion years, and it will continue to shine for billions more. Stars that we see in the night sky may have formed millions or even billions of years ago, and many will continue to shine long after we are gone. The universe operates on a timescale that is difficult to grasp, a slow and patient unfolding of events that spans eons. Black holes are places in space where gravity is so strong that nothing, not even light, can escape. They form when very large stars reach the end of their lives and collapse inward, creating a point of incredible density. Despite their dramatic origins, black holes are not inherently frightening or dangerous unless you are very close to one. Most black holes are very far away, quietly existing in distant parts of the galaxy, exerting their gravitational pull on nearby objects but otherwise remaining still and silent. They do not roam through space seeking things to consume. Instead, they simply exist, a natural part of the universe's structure. Planets and stars all have gravity, a force that pulls things toward them. Gravity is what keeps the planets in orbit around the Sun and what keeps us firmly on the surface of the Earth. It is a gentle, constant force, always present but never harsh. On a planet, gravity pulls everything downward toward the center, creating a sense of weight. In space, far from any planet or star, there is no strong gravitational pull, and objects simply float, drifting in whatever direction they happen to be moving. This weightlessness is a peaceful state, a feeling of being suspended without effort. The Moon orbits the Earth, circling our planet in a slow, predictable path. It takes about a month for the Moon to complete one full orbit, and as it moves, we see different amounts of its surface illuminated by the Sun. These are the phases of the Moon, from the thin crescent to the full, bright circle, and then back again. The Moon's gravity also affects the Earth, causing the tides in our oceans to rise and fall. This gravitational pull is gentle and rhythmic, a quiet interaction between two celestial bodies that has been happening for billions of years. Asteroids are small, rocky objects that orbit the Sun, most of them found in a region between Mars and Jupiter called the asteroid belt. These asteroids are leftover fragments from the early solar system, pieces that never came together to form a planet. They drift along in their orbits, tumbling slowly through space. Most asteroids are very far from Earth, and they pose no concern to us. They are simply part of the natural landscape of the solar system, small and quiet, moving in their own unhurried way. Comets are similar to asteroids but are made of ice and rock. When a comet's orbit brings it close to the Sun, the ice begins to heat up and turn into gas, creating a glowing tail that streams out behind the comet. This tail can stretch for millions of miles, a faint, wispy trail that catches the sunlight. Comets move in long, elliptical orbits, spending most of their time far from the Sun in the cold outer reaches of the solar system. When they do swing close to the Sun, their tails are visible for a brief time before they move away again, returning to the distant cold where they will remain for many years. The planets in our solar system each have their own unique characteristics. Mercury is small and rocky, with a surface covered in craters. Venus is shrouded in thick clouds that trap heat, making it very warm. Earth, our home, has liquid water and a thin atmosphere, conditions that allow life to thrive. Mars is dry and dusty, with a reddish color that comes from iron oxide in its soil. Jupiter is a giant planet made mostly of gas, with swirling clouds and a large storm that has been raging for centuries. Saturn is known for its beautiful rings, made of countless small pieces of ice and rock that orbit the planet. Uranus and Neptune are cold, distant worlds, blue in color and wrapped in thick atmospheres. Each planet is different, yet all of them follow the same basic rules of motion and gravity, drifting along in their orbits around the Sun. Moons are natural satellites that orbit planets. Some planets have many moons, while others have none. Jupiter, for example, has dozens of moons, each one following its own path around the giant planet. Some of these moons are small and irregularly shaped, while others are large and round. One of Jupiter's moons, Europa, is covered in ice and may have a liquid ocean beneath its frozen surface. Another moon, Io, is dotted with volcanoes that erupt slowly, spewing material out into space. Each moon is a small world unto itself, quietly orbiting its planet in the vast expanse of space. Saturn's rings are made of billions of small particles, each one orbiting the planet in a thin, flat disk. These particles range in size from tiny grains to large boulders, and they reflect sunlight, creating the bright, beautiful appearance we see through telescopes. The rings are very thin, only a few hundred meters thick in most places, but they stretch out for hundreds of thousands of kilometers. The particles in the rings move smoothly around Saturn, held in place by the planet's gravity, forming a stable and enduring structure that has existed for millions of years. Space is cold, but not in a harsh or biting way. In the vacuum of space, there is no air to conduct heat, so temperature is determined by the energy received from the sun and other sources. In the shade, far from any star, space can be very cold indeed, close to absolute zero, the lowest possible temperature. But in the sunlight, objects can warm up, heated by the sun's rays. Spacecraft must be designed to manage these temperature differences, using insulation and cooling systems to keep their instruments and crew comfortable. The cold of space is simply a fact, a characteristic of an environment where there is no air and no easy way for heat to spread. The speed of light is the fastest speed at which anything can travel. Light moves at about 300,000 kilometers per second, a speed so fast that it can circle the Earth more than 7 times in a single second. This speed is constant and unchanging, the same in all directions and in all conditions. When we look at distant objects in space, we are seeing them as they were in the past, because the light from those objects has taken time to reach us. A star that is 10 light-years away appears to us as it was 10 years ago, because that is how long it took for its light to travel to Earth. In this way, looking out into space is like looking back in time, a gentle reminder of the vast distances involved. Nebulae are clouds of gas and dust that drift through space. They are often found in regions where stars are being born, the gas and dust slowly coming together under the pull of gravity to form new stars. Nebulae can be very large, spanning many light-years, and they glow softly with light from nearby stars or from the energy released as new stars form within them. Some nebulae are the remnants of old stars that have reached the end of their lives, expanding outward and dispersing their material into space. These clouds are beautiful and serene, gently glowing patches of light against the darkness, slowly changing over millions of years. Star clusters are groups of stars that are close together in space, all of them formed from the same cloud of gas and dust at roughly the same time. There are 2 main types of star clusters. Open clusters contain a few dozen to a few thousand stars, loosely bound together by gravity, and over time, these clusters slowly drift apart as the stars move away from one another. Globular clusters are much larger, containing hundreds of thousands or even millions of stars packed tightly together in a spherical shape. These clusters are very old, some of the oldest objects in the galaxy, and they orbit the Milky Way in long, slow paths. The stars in a globular cluster are bound together by their mutual gravitational pull, a stable and enduring structure that has persisted for billions of years. The idea of floating in space is a peaceful one. Without gravity pulling you down, you would simply drift, moving in whatever direction you happen to be going. There would be no up or down, no sense of falling, just a gentle suspension in the void. Astronauts who have experienced this weightlessness describe it as both strange and calming, a sensation unlike anything on Earth. In space, you could turn and tumble, move in any direction, all without effort, simply by pushing gently off a surface. This freedom of movement is one of the unique aspects of being in space, a quiet and unhurried way of existing. The Earth, seen from space, appears as a small, bright sphere against the darkness. It is mostly blue, covered by oceans, with swirls of white clouds drifting across its surface. Green and brown patches show where the continents are, and at night, tiny lights mark the locations of cities. From space, the Earth looks fragile and beautiful, a small oasis of life in the vast emptiness. This view, often called the overview effect, gives a sense of perspective, a reminder that our planet is just one small part of a much larger universe, a delicate and precious place. Satellites orbit the Earth, moving in carefully planned paths. Some are used for communication, relaying signals from one part of the world to another. Others are used for observation, taking pictures of the Earth's surface or monitoring weather patterns. These satellites drift quietly around the planet, their solar panels glinting in the sunlight, providing services that we often take for granted. They move in silence, far above the noise and bustle of life on the ground, small machines performing their tasks in the vastness of space. The International Space Station is a large spacecraft that orbits the Earth, home to astronauts who live and work there for months at a time. It moves in a steady orbit, circling the planet every 90 minutes or so. Inside, astronauts conduct experiments, observe the Earth, and experience the unique environment of microgravity. The station is a peaceful place, its interior filled with floating equipment and the soft hum of life support systems. Looking out the windows, astronauts can see the curve of the Earth below, the thin line of the atmosphere, and the blackness of space beyond. It is a place where humans have learned to live, at least temporarily, in the quiet expanse beyond our planet. The sun rises and sets from the perspective of someone on the International Space Station not just twice a day, but many times, because the station orbits so quickly. Each orbit brings a new sunrise and a new sunset, the sun appearing and disappearing on the horizon in a rapid cycle. Despite this, the experience is calm and repetitive, a predictable rhythm that becomes familiar to those who live there. The transitions from light to dark and back again are smooth and gentle, a constant reminder of the station's motion through space. Mars has been a subject of quiet fascination for many years. It is a planet not too different in size from Earth, with a day that lasts about 24 hours. Its surface is dry and rocky, covered in dust that gives it a reddish appearance. There are mountains on Mars, some of them much taller than any mountain on Earth, and there are valleys and canyons, carved over time by ancient processes. The atmosphere on Mars is thin, much thinner than Earth's, and the temperature is cold, but the planet is not entirely inhospitable. Robots have been sent to explore Mars, slowly rolling across its surface, taking pictures and analyzing rocks, sending information back to Earth. These robots work patiently, moving a little each day, exploring this distant world in a slow and methodical way. The idea of life elsewhere in the universe is a question that remains open. We have not yet found definitive evidence of life beyond Earth, but the universe is so vast, with so many stars and planets, that it seems possible, even likely, that life exists somewhere. This life might be simple, perhaps just microscopic organisms living in the soil of a distant planet or in the ice of a faraway moon. Or it might be more complex, though we have no way of knowing. The search for life is a patient one, conducted slowly through careful observation and exploration, a gentle quest to understand whether we are alone in the universe. Exoplanets are planets that orbit stars other than the Sun. Thousands of exoplanets have been discovered in recent years, each one orbiting a distant star, too far away to visit but close enough to detect with sensitive instruments. Some exoplanets are large and gaseous, similar to Jupiter. Others are rocky, more like Earth or Mars. A few are in what scientists call the habitable zone, a region around a star where conditions might be right for liquid water to exist. These discoveries are made slowly, through careful measurement and observation, and each new planet adds to our understanding of how common planets are in the universe. Gravity is not just a force that pulls things down, it also shapes the structure of the universe. Stars are held together by their own gravity, and galaxies are bound by the combined gravity of all their stars and other matter. Gravity causes planets to orbit stars and moons to orbit planets, creating the organized systems we observe. On a larger scale, gravity causes galaxies to cluster together, forming groups and superclusters, vast structures that span hundreds of millions of light-years. This gravitational attraction is slow and steady, a gentle pull that has been shaping the universe for billions of years. Dark matter is a term used to describe something we cannot see directly but know must exist because of its gravitational effects. When scientists observe galaxies and clusters of galaxies, they find that there is not enough visible matter to account for the gravitational forces at work. Something else must be there, something that does not emit light or interact with light in a way we can detect, but which has mass and exerts a gravitational pull. This unseen matter is called dark matter, and it makes up a large portion of the universe's total mass. It is a quiet presence, invisible but influential, shaping the motion of galaxies and the structure of the cosmos. Dark energy is another mysterious component of the universe, even less understood than dark matter. Observations show that the expansion of the universe is not slowing down, as one might expect from the pull of gravity, but is instead accelerating, speeding up over time. Something must be causing this acceleration, and that something is called dark energy. It is not something we can touch or see, and we do not know exactly what it is, but it appears to be a property of space itself, a gentle push that causes the universe to expand faster and faster. Dark energy is thought to make up the majority of the universe's total energy, a pervasive and subtle force that influences the cosmos on the largest scales. The concept of infinity is difficult to grasp, but when we think about the universe, it is a concept that often comes to mind. The universe may be infinite in size, stretching on forever in all directions, or it may be finite but so large that the difference is hard to comprehend. Either way, the scale is beyond our everyday experience, a vastness that invites contemplation rather than understanding. This sense of scale can be calming, a reminder that there is so much more than what we can see or touch, a universe that extends far beyond our immediate concerns. Stars are born in nebulae, where clouds of gas and dust slowly collapse under their own gravity. As the material comes together, it heats up, and eventually, the pressure and temperature at the center become high enough for nuclear fusion to begin. This is the moment a star is born, when hydrogen atoms fuse together to form helium, releasing energy in the process. This energy radiates outward, and the star begins to shine. The process is slow, taking thousands or even millions of years from the initial collapse of the cloud to the ignition of fusion, but once it begins, the star can shine steadily for billions of years. When a star reaches the end of its life, what happens depends on its size. Smaller stars, like the Sun, will eventually swell up and then gently shed their outer layers, leaving behind a dense core called a white dwarf. This core will cool slowly over billions of years, fading from white to eventually a dim brown or black. though this process takes so long that no white dwarf has yet had time to cool completely. Larger stars have a more dramatic end, but even this process, when viewed on cosmic timescales, is a slow and predictable one. The star runs out of fuel, its core collapses, and the outer layers are expelled into space, sometimes creating a beautiful nebula. The core may become a neutron star or, if the star is large enough, a black hole. These remnants are dense and stable, objects that will persist for an incredibly long time. Neutron stars are the dense remnants of massive stars that have collapsed. They are incredibly compact, with a mass greater than the Sun but compressed into a sphere only a few kilometers across. The density is so great that a single spoonful of neutron star material would weigh as much as a mountain. Despite their extreme properties, neutron stars are stable objects, spinning slowly, or sometimes very quickly, and emitting faint radiation. Some neutron stars emit regular pulses of radio waves, and these are called pulsars. The pulses are like a lighthouse beam, sweeping around as the star rotates, a regular and predictable signal that has been observed for many decades. The concept of time in space is also interesting to consider. Time passes at the same rate for everything, but when speeds approach the speed of light or when gravity is very strong, time can appear to pass at different rates for different observers. This is a consequence of Einstein's theory of relativity, which describes how space and time are connected. For most purposes, these effects are tiny and unnoticeable, but they have been measured and confirmed through precise experiments. Time is a flexible concept, dependent on motion and gravity, though in our everyday experience, it flows steadily and predictably. The planets and moons in our solar system are all unique. Some, like Mercury and the Moon, are covered in craters, the scars of ancient impacts. Others, like Venus, have thick atmospheres that obscure their surfaces. Earth is the only planet we know of with liquid water on its surface and an atmosphere that supports life. Mars has polar ice caps and evidence of ancient riverbeds, suggesting that water once flowed there. The gas giants, Jupiter and Saturn, have complex weather systems, with swirling clouds and powerful storms that persist for years or even centuries. Uranus and Neptune, the ice giants, are cold and distant, their atmospheres containing methane that gives them their blue color. Each world is a place of interest, a small piece of the larger puzzle of how the solar system formed and evolved. The motion of objects in space is governed by simple, predictable laws. Newton's laws of motion describe how objects move and how forces affect them, and these laws apply throughout the universe. An object in motion will continue moving in a straight line unless a force acts on it. When a force does act, the object accelerates in the direction of that force. For every action, there is an equal and opposite reaction. These principles are straightforward and universal, applying to everything from falling apples to orbiting planets to distant galaxies. The motion of the cosmos is orderly and predictable, a vast clockwork that runs smoothly without intervention. Spacecraft travel through space by following these same laws. Once a spacecraft is launched and reaches a certain speed, it will continue moving through space without needing to burn fuel constantly, because there is no air resistance to slow it down. Gravity from planets and the Sun can be used to change a spacecraft's path, a technique called a gravity assist or slingshot. By carefully planning the trajectory, spacecraft can gain speed and change direction without using much fuel, simply by passing close to a planet and using its gravity to alter their course. This is a patient and efficient way to travel, taking advantage of the natural motion of the solar system. The Voyager spacecraft, launched in the late 1970s, are now the farthest human-made objects from Earth. They have traveled beyond the orbit of Neptune, beyond the region where the Sun's influence is strongest, and into interstellar space. They continue to move outward, slowly drifting through the void, their instruments still sending back faint signals that take hours to reach Earth. These spacecraft will continue traveling for thousands or even millions of years, silent messengers carrying information about humanity into the cosmos. Their journey is a slow one, measured in decades and centuries, a gentle drift through the vastness of space. When we think about our place in the universe, it can provide a sense of perspective. We live on a small planet, orbiting an average star, in a typical galaxy among billions of others. The universe is vast and ancient, and we are a small part of it. This perspective can be humbling, but it can also be comforting, a reminder that we are part of something much larger. The stars that shine in the night sky have been there for billions of years, and they will continue to shine for billions more. The universe is a stable, enduring place, and we are fortunate to be able to observe it and wonder at it. The light from stars takes time to reach us, and this means that when we look at the night sky, we are looking back in time. The light from the nearest star beyond the Sun takes just over 4 years to reach us, so we see that star as it was 4 years ago. More distant stars are seen as they were hundreds or thousands of years ago, and distant galaxies are seen as they were millions or billions of years ago. This effect is not something we can change or avoid. It is simply a consequence of the finite speed of light and the vast distances involved. It gives us a window into the past, allowing us to observe the universe as it was at different times in its history. The universe is thought to be about 13.8 billion years old, a number that is almost impossible to comprehend. In that time, galaxies have formed and evolved, stars have been born and died, and planets have formed around those stars. The universe has changed, but it has done so slowly, on timescales that dwarf human history. The processes that shape the cosmos are patient and gradual, unfolding over millions and billions of years. This slow pace is part of what makes the universe feel so stable and enduring, a place where change happens, but it happens gently and without haste. The sun will continue to shine for billions of years, providing light and warmth to the earth. Eventually, it will run out of fuel and begin to change, but this will not happen for a very long time, far longer than humans have existed. The sun is stable and reliable, a constant presence in our lives, and it will remain so for the foreseeable future. This stability is comforting, a reminder that the cosmos operates on timescales that are much longer than our own, and that the changes we observe are gradual and predictable. Looking up at the night sky, we can see only a tiny fraction of the universe. Most of it is too far away, too faint, or too obscured by dust and gas for us to observe directly. Yet even the small portion we can see is filled with countless stars and galaxies, each one a world unto itself. The universe is vast beyond imagination, filled with more stars than grains of sand on all the beaches of Earth, and each of those stars may have planets of its own. The sheer scale of it all is difficult to grasp, but it can also be a source of wonder, a reminder of the richness and complexity of the cosmos. Space is a place of contrasts. It is vast, yet filled with tiny details. It is empty, yet full of structure. It is ancient, yet constantly changing. These contrasts are part of what makes space so fascinating, a place that invites exploration and contemplation. Despite its size and complexity, the universe operates according to simple, understandable laws, and these laws can be studied and appreciated by anyone willing to look up and wonder. The experience of looking at the stars can be a peaceful one. On a clear night, far from city lights, the sky is filled with countless points of light, each one a distant sun. The Milky Way stretches overhead, a faint band of light that hints at the vast number of stars in our galaxy. Planets move slowly against the background of stars, following their predictable paths. Meteors occasionally streak across the sky, brief flashes of light as tiny particles burn up in the atmosphere. The sky is a window into the universe, a view of the cosmos that has been available to every human who has ever lived. The universe does not require our understanding or appreciation. It simply is, existing and evolving according to its own laws. Yet we are fortunate to be able to observe it, to wonder at it, and to try to understand it. This act of observation and contemplation is a peaceful one, a way to connect with something much larger than ourselves. The universe is vast and ancient, filled with wonders and mysteries, and it invites us to look, to wonder, and to appreciate the quiet beauty of the cosmos. Space is not a place of danger or drama, but of slow, patient processes that unfold over immense periods of time. Stars shine, planets orbit, galaxies drift through the void, all following the same simple laws that have governed the universe since its beginning. This predictability and order can be comforting, a reminder that the cosmos is a stable and enduring place, a vast expanse where everything has its place and moves in its own unhurried way. The Moon, our closest neighbor in space, has been a source of wonder for as long as humans have existed. It drifts across the sky, changing shape from night to night as the sun illuminates different parts of its surface. Its surface is covered in craters, the scars of ancient impacts, and its gray, dusty plains are dotted with mountains and valleys. The Moon has no atmosphere, so the sky above it is always black, even during the lunar day. It is a quiet, still place, unchanged for billions of years, a constant companion to the Earth as it moves through space. The planets and stars follow their paths with a regularity that can be measured and predicted. Astronomers can calculate where a planet will be years or even centuries in the future, because the motion of celestial bodies is so predictable. This regularity is one of the defining features of the universe, a sense of order and structure that underlies everything. Despite the vastness and complexity of the cosmos, there is a simplicity to its motion, a rhythm that can be understood and appreciated. When we think about space, it is easy to focus on the dramatic or the exotic, the black holes, the supernovae, the vast distances. But space is also a place of quiet beauty, of gentle processes that unfold slowly over time. It is a place where light travels for years to reach us, where stars shine steadily for billions of years, where galaxies drift through the void in a slow, graceful dance. This quietness is part of what makes space so appealing, a realm where the pace is slow and the scale is vast, a place that invites contemplation and wonder. The experience of floating in space, of being weightless, is one that few people have had, but it is a powerful one. Without gravity pulling you down, you simply drift, suspended in the void, moving slowly and smoothly without effort. There is no up or down, no sense of falling, just a gentle suspension. This feeling of weightlessness is unlike anything on Earth, a unique experience that offers a different perspective on motion and existence. It is a calm, peaceful state, a way of being that is free from the constant pull of gravity. The sun's light, when it reaches Earth, has traveled through the vacuum of space, through the emptiness, to bring warmth and brightness to our world. This light is steady and reliable, a constant presence that has sustained life on Earth for billions of years. The sun rises each morning and sets each evening, a predictable rhythm that governs our days and our lives. This constancy is comforting, a reminder that the universe operates according to simple, predictable laws, and that the sun will continue to shine for a very long time. Stars are not all the same. Some are small and dim, glowing with a reddish light. Others are large and bright, shining with a bluish or white light. The color of a star depends on its temperature, with hotter stars appearing blue and cooler stars appearing red. Each star is unique, with its own size, brightness, and color, yet all of them follow the same basic processes, shining steadily as they convert hydrogen into helium deep within their cores. This diversity within simplicity is one of the appealing aspects of the universe, a place where each object is different, yet all are governed by the same laws. The universe is a place of patterns and rhythms. Planets orbit stars, moons orbit planets, stars orbit the centers of galaxies, and galaxies themselves move through the universe. These orbits are smooth and predictable, following paths that are determined by gravity. There is a regularity to the motion of celestial bodies, a sense of order that persists across the vastness of space. This order is not imposed from outside but arises naturally from the laws of physics, a self-organizing structure that has existed for billions of years. The idea of the universe as a whole, as a single, vast entity, is one that can be both overwhelming and comforting. On the one hand, the scale is almost incomprehensible, the distances so great and the timescales so long that they dwarf human experience. On the other hand, the universe is governed by simple, understandable laws, and these laws apply everywhere, from the smallest particles to the largest galaxies. This universality is reassuring, a reminder that the cosmos is a place of order and predictability, a vast but comprehensible whole. When astronauts return from space, they often speak of the profound effect of seeing the Earth from a distance, of recognizing how small and fragile our planet appears against the vastness of space. This perspective, sometimes called the overview effect, can change how one thinks about the world and our place in it. It is a reminder that we are all connected, that we share a single, small planet in the immense expanse of the universe, and that this planet is precious and worth caring for. This sense of perspective is one of the gifts that space exploration has given us, a way of seeing ourselves and our world in a broader context. The universe is filled with light, from the glow of distant stars to the faint radiation that fills all of space, a remnant of the universe's earliest moments. This light is everywhere, permeating the cosmos, a gentle presence that has been traveling through space for billions of years. Some of this light is visible to our eyes, but much of it is not, existing at wavelengths that we cannot see without special instruments. Yet all of it is there, filling the universe with energy and information, a constant presence in the vastness of space. Space is not empty in the sense of being devoid of everything, but rather it is mostly empty, with occasional pockets of matter scattered throughout. Stars and planets and galaxies are separated by vast distances, but they are all connected by the fabric of space itself, a medium through which light and gravity propagate. This fabric is smooth and continuous, stretching across the universe, a backdrop against which all events unfold. It is a subtle presence, one that we do not often think about, but it is fundamental to the structure of the cosmos. The motion of light through space is constant and unchanging. Light always travels at the same speed, regardless of the motion of its source or the observer. This constancy is one of the fundamental properties of the universe, a fact that has profound implications for how we understand space and time. Light is the fastest thing in the universe, and nothing can travel faster than it. This speed limit is not arbitrary but is built into the very structure of space and time, a natural consequence of the laws of physics. When we look at distant galaxies, we see them as they were billions of years ago, because that is how long it has taken for their light to reach us. These galaxies are receding from us, carried away by the expansion of the universe, and the light from them is stretched and reddened as it travels through expanding space. This effect, called redshift, is a gentle and predictable consequence of the universe's expansion, a way in which the motion of the cosmos affects the light we observe. It is a reminder that the universe is dynamic, that it is changing, but that these changes happen slowly and predictably. The night sky is a source of wonder and contemplation, a view into the vastness of the universe. Each star is a sun, each galaxy a collection of billions of stars, and the distances between them are so great that light takes years or centuries or millennia to travel from one to another. Yet despite these vast distances, we can observe and study the universe, learning about its structure and history, its composition and evolution. This ability to observe and understand the cosmos is a remarkable achievement, a testament to human curiosity and ingenuity. Space is a place where time and distance take on new meanings. A journey that would take years or decades on Earth might take only minutes in space, if you could travel fast enough. But the speed of light is the ultimate limit, and even at that speed, the universe is so large that it would take billions of years to cross it. This vastness can be difficult to comprehend, but it is also a source of beauty and wonder, a reminder of the richness and complexity of the cosmos. The stars that shine in the night sky have been there for billions of years, and they will continue to shine for billions more. They are stable and enduring, providing a constant backdrop against which human history unfolds. The constellations we see today are the same constellations that our ancestors saw thousands of years ago, and they will be the same constellations that future generations will see thousands of years from now. This constancy is comforting, a reminder that the universe is a stable and enduring place, a vast expanse where change happens slowly and predictably. The universe is a place of quiet beauty, of slow processes that unfold over immense periods of time. It is a place where stars shine, planets orbit, and galaxies drift through the void, all following the same simple laws that have governed the cosmos since its beginning. This simplicity and order are part of what makes the universe so appealing, a realm where complexity arises from simple principles, where the vast and the tiny are connected by the same fundamental laws. When we look up at the night sky, we are looking out into the universe, seeing the light from distant stars and galaxies, observing the cosmos as it was in the past. This act of observation is a way of connecting with something much larger than ourselves, a way of appreciating the beauty and complexity of the universe. The stars shine steadily, the planets move in their predictable paths, and the cosmos continues its slow, graceful evolution, a vast and ancient expanse that invites us to look, to wonder, and to appreciate its quiet splendor.